Continue with the trig substitution. So the next case we're going to talk about is the square root of a squared plus x squared situations. For this kind of situation, we're going to let x to be the a times tangent of theta. Then the derivative of x is going to be a times secant squared theta d theta. Using the right triangles, theta, the tangent theta is going to be x over a, so that means the opposite over the adjacent is x and a. The hypotenuse is square root of a squared plus x squared. So let's looking at one example here. So we want to find the integral of x over square root of x squared plus 4. So we're going to let x equals to 2 tangent theta, because 4 is 2 squared. Then the dx is going to be 2 secant squared theta d theta. Now we can replace the x and the dx as 2 tangent theta over square root of 4 tangent squared theta plus 4. And then the dx will become to 2 secant squared theta d theta. The square root of 4 tangent squared theta plus 4 can rewrite it as 4 times tangent squared theta plus 1. And according to the Pythagorean theorem, tangent squared theta plus 1 is going to be secant squared theta. So both 4 and the secant squared theta are the perfect square, so the denominator can rewrite as 2 times secant theta. Now we can simplify everything. To have the constant 2 out and got tangent theta secant theta d theta, and we know that is the derivative of the secant theta. But we are not looking for theta, we're looking for x. So x equal to 2 times tangent theta, so tangent theta is going to be x over 2. So the opposite is going to be x, the adjacent is going to be 2, and then the hypotenuse is going to be square root of 4 plus x squared. And secant is 1 over cosine, which is the hypotenuse over the adjacent, which is square root of 4 plus x squared over 2. Replace secant theta and simplify the 2. We got square root of 4 plus x squared plus c as the final answer. Let's look at another example, which is integral 1 over x squared times square root of x squared plus 4, where square root of x squared plus 4 is the form of square root of x squared plus a squared. So we can let x equals to 2 tangent theta, and dx is going to be 2 secant theta secant square theta. Replace the x's. We got 4 tangent square theta for the x squared, and square root of 4 tangent square theta plus 4 for the square root of x squared plus 4, and d theta is going to be 2 secant square theta d theta. where the square root of 4 tangent square theta plus 4 could be rewrite as 2 secant theta. And simplified everything. We got secant theta over tangent square theta. It is a little bit harder to work directly with secant and tangent, so we're going to rewrite everything in terms of sine and cosine. So secant is 1 over cosine. And secant over tangent squares, we can also thinking about that as a division. And tangent is going to be sine over cosine. So divide by fraction is the same as the multiply by the reciprocal. So we multiply the cosine square theta on the top over sine square theta. Simplify them. We got cosine theta over sine square theta. We can use the u sub. U equal to sine of theta, and du is equals to cosine theta d theta. We got 1/4 integral of 1 over u squared, which is u to the negative second power. The antiderivative of that is going to be 1 over the negative 2 plus 1 times u to the negative 2 plus 1, which is negative u to the negative 1's power. But we're not talking about u nor theta. We have to rewrite everything in terms of x. So first, we're going to rewrite u back as sine of theta. Then, using the triangle, we know tangent, 2 tangent theta equal to x. So tangent of theta is x over 2. So the opposite and then adjacent hypotenuse is square root of x squared plus 4. One over sine theta is cosecant theta. And the cosecant is going to be the hypotenuse over the opposite, which is square root of x squared plus 4 over x. Multiply the 1/4 we had originally, so we got negative square root of x squared plus 4 over 4x plus c.